Good morning. A warm welcome to all. Respected Principal, Dr. Bridget Paul, Vice Principal, Father Dr. Xavier CS, IQAC Coordinator, Dr. Matthew Stitelli, NAB Coordinator, Dr. Sandhya C, our eminent speaker, Dr. Blesson Matthew, Head of the Department, Ms. DTS Nair, my colleagues, and all the participants. I myself, Sonia NV, faculty member of the Department of Electronics. Hope all you are safe. If you want to bright like a sun, first you burn like a sun. Salutations and tributes to an institution who taught us to dream, the legendary great Dr. P J Abdul Kalam. Thank you for joining us for today's webinar on astrophysics organized by the Department of Electronics in association with IQAC K College, Mannanam. Once again, I welcome you all. Now, I invite our student, Ms. Nivedya Raj, to compare the program. Nivedya, please.
Thank you, ma'am, for giving me this opportunity. Good morning to all. I would like to welcome our honored dignitaries, our principal, Dr. Bridget Paul, ma'am, who constantly provides us with immense support on both curricular and non-curricular activities. Next, our Vice Principal, Father Xavier CS, whose guidance to the students cannot be matched. Next, IQAC Coordinator, Dr. Matthew T. Thallisar, whose contribution to the college and the IQAC cell is tremendous. Then we invite NAC Coordinator, Dr. Sandhya ma'am, Program Coordinator, Ms. Sonia NV ma'am, and HOD of Electronics Department, Mrs. DTS Nair ma'am. Also, I would like to welcome our eminent speaker, Dr. Blesson Matthew sir. Now let me invite our respected principal, Dr. Bridget Paul ma'am, to officially inaugurate this national webinar.
Good morning all. College Vice Principal, Dr. Father Xavier CS, IQAC Coordinator, Dr. Matthew Stitelli, NAC Coordinator, Dr. Sandhya C, Electronics Faculty Members, DTS Nair, Sonia NV, all other participants. എല്ലാവർക്കും ഒരു നല്ല പ്രഭാതം ആശംസിക്കുന്നു. ഡോക്ടർ APJ അബ്ദുൽ കലാമിൻ്റെ സ്മരണയ്ക്ക് മുമ്പിൽ ആദരാഞ്ജലികൾ അർപ്പിച്ചുകൊണ്ട് നമുക്ക് ഈ വെബിനാർ ആരംഭിക്കാം. 2 മാസങ്ങളായി കെ കോളേജ് തുടർച്ചയായി വെബിനാറുകൾ നടത്തിക്കൊണ്ടിരിക്കുകയാണ്. പല വിഷയങ്ങളിൽ പല പ്രശസ്തരായ റിസോഴ്സ് പേഴ്സൺസ് എല്ലാവരും ഇതിൽ പങ്കെടുക്കുന്നുണ്ട്. ഇതിൽ ഒരു പുതിയ എപ്പിസോഡ് ഇന്ന് എഴുതി ചേർക്കുകയാണ്. ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെന്റിന്റെ ആഭിമുഖ്യത്തിൽ ആസ്ട്രോഫിസിക്സിനെ പറ്റി ഒരു വെബിനാറാണ് ഇപ്പോൾ നമ്മൾ ആരംഭിക്കുന്നത്. ആസ്ട്രോഫിസിക്സ് എന്ന് പറഞ്ഞാൽ നമുക്ക് അധികം ആർക്കും അത്ര പരിചയമുള്ള ഒരു ഫീൽഡ് അല്ല. എങ്കിലും നമ്മുടെ ഭാരതത്തിന്റെ തന്നെ അഭിമാനമായ ഡോക്ടർ APJ അബ്ദുൽ കലാമിന്റെ സ്മരണയ്ക്ക് മുമ്പിലാണ് നമ്മൾ ഇന്ന് എല്ലാവരും ഒത്തുചേർന്നിരിക്കുന്നത്. ഭാരതത്തെ മാത്രമല്ല ലോകത്തെ മുഴുവനും ആത്മവിശ്വാസത്തിന്റെയും കഠിനാധ്വാനത്തിന്റെയും ലളിത ജീവിതത്തിന്റെയും പാഠങ്ങൾ പഠിപ്പിച്ച ഡോക്ടർ APJ അബ്ദുൽ കലാമിന്റെ സ്മരണാർത്ഥം ഈ ഒരു വെബിനാർ ഇവിടെ കാഴ്ചവെക്കുന്ന ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെന്റിനെ ഞാൻ ആദ്യമായി തന്നെ അഭിനന്ദിക്കുകയാണ്. ഒരു നല്ല ശാസ്ത്രജ്ഞനായിരുന്നതോടൊപ്പം തന്നെ ഒരു നല്ല രാഷ്ട്രതന്ത്രജ്ഞനും നല്ലൊരു മനുഷ്യസ്നേഹിയും ആയിരുന്നുകൊണ്ട് ഋഷിതുല്യമായ ഒരു ജീവിതം നയിച്ച അദ്ദേഹത്തിന്റെ സ്മരണയ്ക്ക് മുമ്പിൽ നമുക്ക് ഒന്നുചേരാം. ഈ ഒരു വെബിനാർ നയിക്കുന്നത് നമ്മുടെ റിസോഴ്സ് പേഴ്സണായിട്ട് എത്തിയിരിക്കുന്നത് ഡോക്ടർ ബ്ലെസൻ മാത്യു ആണ്. അദ്ദേഹത്തിന്റെ വിഷയത്തിലുള്ള അഗാധമായ പാണ്ഡിത്യം ആസ്ട്രോഫിസിക്സിനെ സ്നേഹിക്കുന്ന എല്ലാവർക്കും അതിൽ നിന്നും കൂടുതൽ അറിവ് നേടാൻ സാധിക്കട്ടെ എന്ന് ആശംസിച്ചുകൊണ്ട് ഇന്നത്തെ ഈ വെബിനാർ ഞാൻ ഉദ്ഘാടനം ചെയ്യുന്നു. താങ്ക് യു.
Thank you, ma'am, for inaugurating this event. Next, I would like to invite our respected Vice Principal, Father Xavier CS, to shower his words of blessing.
എല്ലാവർക്കും എൻ്റെ വിനീതമായ നമസ്കാരം. നല്ലൊരു സുപ്രഭാതം ഞാൻ ആശംസിക്കുന്നു. എല്ലാവർക്കും എന്നെ കേൾക്കാമെന്ന് ഞാൻ വിചാരിക്കുകയാണ്. ആദരണീയായ കോളേജിൻ്റെ പ്രിൻസിപ്പൽ ഡോക്ടർ ബ്രിജിറ്റ് പോൾ, കോളേജിൻ്റെ IQAC കോർഡിനേറ്റർ ഡോക്ടർ മാത്യു സ്റ്റിറ്റർലി, കോർഡിനേറ്റർ ഡോക്ടർ സന്ധ്യ, കോളേജിൻ്റെ ഫിസിക്സ് വിത്ത് അപ്ലൈഡ് ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെൻറ്റിൻ്റെ സാരഥിയായ ദീപ്തി, ഈ വെബിനാറിൻ്റെ കോർഡിനേറ്റർ സോണിയ, ഡിപ്പാർട്ട്മെൻറ്റിലെ മറ്റ് അധ്യാപകരായ അനീഷ്, ശ്രുതി, സുനു, ഈ വെബിനാറിൽ പങ്കെടുക്കുന്ന മറ്റ് അധ്യാപകർ, വിദ്യാർത്ഥികൾ, എല്ലാവർക്കും ഒരിക്കൽ കൂടി എൻ്റെ വിനീതമായ നമസ്കാരം. ആസ്ട്രോഫിസിക്സിനെ കുറിച്ച് സംസാരിക്കാൻ എന്തുകൊണ്ടും യോഗ്യമായ ഒരു ദിവസമാണ് ഇന്ന്. ഇന്ത്യയുടെ മിസൈൽ മാൻ എന്നറിയപ്പെടുന്ന ഡോക്ടർ P J അബ്ദുൽ കലാമിൻ്റെ 5ാം മരണവാർഷികമാണിന്ന്. രാജ്യത്തിന് വേണ്ടി സ്വന്തം ജീവൻ ബലി കഴിച്ച, ജീവിതത്തിൽ ലഭിക്കാമായിരുന്ന എല്ലാ സൗഭാഗ്യങ്ങളെയും ഉപേക്ഷിച്ചുകൊണ്ട് രാജ്യത്തിന് വേണ്ടിയിട്ട്, രാജ്യത്തിൻ്റെ നല്ല നാളേക്ക് വേണ്ടിയിട്ട് ജീവിച്ച അനന്യയാണ് APJ അബ്ദുൽ കലാം. പ്രസിദ്ധമായ, എന്നെ വളരെ സ്വാഗതമാണ് എനിക്ക് തോന്നുന്നു വെബിനാർ സംഘടിപ്പിക്കുമ്പോൾ ഇതിനെക്കുറിച്ച് എനിക്ക് വലിയ നോളജ് ഒന്നുമില്ല. ഇതിനെക്കുറിച്ച് തടഞ്ഞു നിർത്തുന്ന ഒരു, തീർച്ചയായിട്ടും നമ്മൾ വേണ്ടിയിട്ട് നാം പലപ്പോഴും നമ്മുടെ ജീവിതത്തിന്റെ ഭാഗമാക്കി തീർക്കാൻ നമ്മൾ അറിവ് മഹാന്മാരാക്കുക മാത്രമാണ് നമ്മെ മനുഷ്യരാക്കി തീർക്കുക എന്നുള്ള വലിയ പാഠം സ്വജീവിതത്തിലൂടെ അവതരിപ്പിച്ച മനുഷ്യനാണ് APJ അബ്ദുൽ കലാം. തീർച്ചയായിട്ടും ഇന്ന് ഈ ഒരു ദിവസം എന്തുകൊണ്ട് നമ്മൾ ആസ്ട്രോഫിസിക്സിനെ കുറിച്ച് ചിന്തിക്കണം, എന്തുകൊണ്ട് നമ്മൾ ആസ്ട്രോഫിസിക്സിനെ കുറിച്ച് അറിയണം വിഷയത്തിൽ വെബിനാർ സംഘടിപ്പിച്ച കോളേജിലെ സെൽഫ് ഫിനാൻസ് ഫിസിക്സ് വിത്ത് അപ്ലൈഡ് ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെന്റിലെ എല്ലാ അധ്യാപകരെയും അനധ്യാപകരെയും വിദ്യാർത്ഥികളെയും ഞാൻ മനസ്സ് നിറഞ്ഞ് അഭിനന്ദിക്കുകയാണ്. അതിന് നേതൃത്വം കൊടുക്കുന്ന കോർഡിനേറ്റർ ഡോക്ടർ മാത്യു സ്റ്റിറ്റർലി, അതിനെല്ലാവിധത്തിലുമുള്ള സാങ്കേതികമായ സഹായങ്ങൾ ചെയ്യുന്ന ഷിബിന്, കോളേജിൻ്റെ കോർഡിനേറ്റർ, ഇവരുടെ എല്ലാവരുടെയും നിസ്തുലമായ സേവനവും ഇവരുടെ എല്ലാവരുടെയും സഹകരണവും കൊണ്ട് മാത്രമാണ് ഇത്തരമൊരു വെബിനാർ നമുക്ക് സംഘടിപ്പിക്കാനായിട്ട് സാധിക്കുന്നത്. കോളേജിലെ വിവിധ ഡിപ്പാർട്ട്മെൻറ്റിൽ വിഷയങ്ങളിലായിട്ട് അനവധിയായ വെബിനാറുകൾ നടക്കുന്നു. IQACയുടെ നേതൃത്വമാണ് അതിൻ്റെ പിന്നിലെല്ലാം തന്നെ. പ്രത്യേകിച്ച് സെൽഫ് ഫിനാൻസ് സ്ട്രീമിൽ നിന്നും ഫിസിക്സ് ഡിപ്പാർട്ട്മെൻറ്റ് ഇങ്ങനെ ഒരു വെബിനാർ സംഘടിപ്പിക്കുന്നതിൽ വളരെയധികം സന്തോഷമുണ്ട്. ഇതൊരു തുടക്കമാവട്ടെ, മറ്റെല്ലാവർക്കും ഇത് കുറെ കൂടി ഗൗരവമായിട്ട് നമ്മുടെ അക്കാദമിക രംഗത്തെ സമീപിക്കുന്നതിന് സഹായകമായി തീരട്ടെ എന്ന് ഞാൻ ആശംസിക്കുന്നു. ഇതിന് നേതൃത്വം കൊടുത്തിരിക്കുന്ന ഡിപ്പാർട്ട്മെന്റ് ഹെഡ് ദീപ്തി, കോർഡിനേറ്റർ സോണിയ എന്നിവരെ ഒരിക്കൽ കൂടി ഞാൻ അഭിനന്ദിക്കുന്നു. ഈ സെമിനാർ ഒരു വിജയമായി തീരട്ടെ. അതോടൊപ്പം തന്നെ ഇന്നത്തെ റിസോഴ്സ് പേഴ്സണായിട്ട് കോളേജിൻ്റെ തന്നെ അലുമിനസ് ആയിട്ടുള്ള ബ്ലസൻ മാത്യുവാണ്. ബ്ലസൻ മാത്യുവിന് കോളേജിലേക്ക്, ആത്മമാത്രയിലേക്ക് ഒരിക്കൽ കൂടി സ്നേഹപൂർണ്ണമായ സ്വാഗതം. വളരെയധികം സന്തോഷവും അഭിമാനവും തോന്നുന്നുണ്ട്. കോളേജിൻ്റെ ഒരു പൂർവ്വ വിദ്യാർത്ഥിയായ ബ്ലസൻ ഇന്ന് റിസോഴ്സ് പേഴ്സണായിട്ട് ഈ ഒരു സംഘടിപ്പിക്കുന്നത് കാണുമ്പോൾ ബ്ലസനെ ഞാൻ കോളേജിലേക്ക് നിറഞ്ഞ സ്നേഹത്തോടെ, സന്തോഷത്തോടെ, അഭിമാനത്തോടു കൂടി സ്വാഗതം ചെയ്യുന്നു. ഈ വെബിനാറിന് എല്ലാവിധ വിജയാശംസകളും നേരുന്നു. ദൈവം നമ്മെ എല്ലാവരെയും ധാരാളമായി അനുഗ്രഹിക്കട്ടെ. നന്ദി.
Thank you, Father, for your kind words. Next, I would like to invite our IQAC coordinator, Dr. Matthew T. Telly, to felicitate the occasion.
കോളേജിന്റെ സാരഥി ഏറ്റവും ബഹുമാനപ്പെട്ട ബ്രിജിറ്റ് മിസ്, സ്നേഹ ബഹുമാനപ്പെട്ട വൈസ് പ്രിൻസിപ്പൽ സേവറച്ച, നാക് കോർഡിനേറ്റർ സന്ധ്യ മിസ്, ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെന്റിലെ സുനു മിസ്, സോണിയ, ദീപ്തി മിസ്, മറ്റ് അധ്യാപകരെ, ഈ സെമിനാറിൽ പങ്കെടുക്കുന്ന എല്ലാവർക്കും കുടുംബത്തിലേക്ക് സ്നേഹപൂർവ്വം സ്വാഗതം ചെയ്തുകൊള്ളുന്നു. അതോടൊപ്പം തന്നെ ഇന്നത്തെ റിസോഴ്സ് പേഴ്സണായ കോളേജിന് അഭിമാനമായ ബ്ലസൻ സാറിനെയും സ്നേഹത്തോടെ കുടുംബത്തിലേക്ക് സ്വാഗതം ചെയ്തുകൊള്ളട്ടെ. അബുൽ ഫക്കീർ ജൈനുലുദ്ദീൻ അബ്ദുൽ കലാം, ഭാരതത്തിന്റെ പ്രഥമ പുരുഷൻ, 11ാമത്തെ സ്ഥാനം വഹിച്ച പ്രഥമ പുരുഷൻ, ഭാരതത്തിന്റെ മിസൈൽ മാൻ, നമ്മെ വിട്ടുപിരിഞ്ഞിട്ട് ഇന്ന് 5 വർഷം പൂർത്തിയാകുകയാണ്. ശാസ്ത്ര സാങ്കേതിക മേഖലയിൽ അമൂല്യമായ സംഭാവനകൾ നൽകി ഭാരതത്തിന്റെ സ്വകാര്യ അഹങ്കാരത്തിന്റെ ഉടമ, ഭാരതത്തിന്റെ യുവാക്കളെ ഊർജ്ജസ്വലമാക്കിയ അദ്ദേഹത്തിന്റെ പ്രവർത്തികൾ, അദ്ദേഹത്തിന്റെ വാക്കുകൾ എന്നും നമ്മളിൽ പ്രചോദനമാണ് നൽകുന്നത്. അദ്ദേഹത്തിന്റെ 1-2 വാക്കുകളിലേക്ക് കടന്നാൽ, ഉറങ്ങുമ്പോൾ കാണുന്നതല്ല നമ്മുടെ ഉറക്കം നഷ്ടപ്പെടുത്തുന്നതാണ് സ്വപ്നം എന്നതും, അതോടൊപ്പം തന്നെ സ്വപ്നം കാണുക, ആ സ്വപ്നങ്ങളെക്കുറിച്ച് ചിന്തിക്കുക, ആ ചിന്തകളെ പ്രവൃത്തിയുടെ സഫലമാക്കുക എന്നീ വാക്കുകൾ, സ്വപ്നത്തിൻ്റെതായ വാക്കുകൾ എല്ലാ യുവാക്കളിലും ഊർജം നൽകുന്നതാണ്. അദ്ദേഹത്തിന്റെ സ്മരണയ്ക്ക് മുമ്പിൽ ആദരാഞ്ജലികൾ അർപ്പിച്ചുകൊണ്ട് ഇന്ന് ഈ വെബിനാർ സംഘടിപ്പിച്ച ഡിപ്പാർട്ട്മെന്റ് ഓഫ് ഇലക്ട്രോണിക്സ്, കോളേജ് മന്നാനം സെൽഫ് ഫിനാൻസിംഗ് ഡിപ്പാർട്ട്മെന്റ് ആയ ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെന്റിലെ എല്ലാവർക്കും, അതുപോലെ തന്നെ ഇതിൽ ശ്രോതാക്കളായ പാർട്ടിസിപ്പൻസ് ആയ എല്ലാവരെയും നല്ലൊരു ദിനം നേർന്നുകൊണ്ട്, നല്ല ഒരു സ്വപ്നം കാണാനുള്ള, ഉറക്കം കെടുത്തുന്ന സ്വപ്നം സാഫല്യമാക്കാനുള്ള ഒരു നല്ല ഇന്ത്യയെ ഈ കോവിഡ് കാലഘട്ടത്തിൽ പടുത്തുയർത്താൻ നമുക്ക് ഏവർക്കും പരിശ്രമിക്കാം എന്ന് ആശംസിച്ചുകൊണ്ട് ഞാൻ എന്റെ വാക്കുകൾ നിർത്തട്ടെ. നന്ദി.
Thank you, sir, for all your support. Next, I would like to invite our program coordinator, Ms. Sonia Envy, to introduce our eminent speaker, Dr. Blesson Matthew.
Good morning, ladies and gentlemen. Today, this task of introducing our guest of honor and speaker is a great privilege. I know this one is difficult, but the thought that he is a man of virtue and simplicity. I feel elated to introduce Dr. Blesson Matthew, Assistant Professor, Christ University, Bengaluru, to everyone today. Dr. Blesson Matthew. After finishing MSc Physics from CUSAT, he joined PhD at Indian Institute of Astrophysics, Bengaluru. He holds postdoctoral positions at Physical Research Laboratory, Ahmedabad, Swinburne University of Technology, Australia, and Tata Institute of Fundamental Research, Mumbai. After that, he joined Christ University, Bengaluru, and have been assistant professor there since 2017. During this period, along with teaching and academic activities, he managed to develop a research team of 7 PhD students and 2 MPhil students. He had published about 30 research papers in referred journals of national or international repute. Now, without further ado, I will turn the time over to Dr. Blesson Matthew, our eminent speaker. Welcome you, sir.
Thank you very much. It's an honor. It's an honor. Thank you very much for this invitation. Especially thank Sonia Madam. So when she asked me to give this presentation, it was a great honor. I mean, I was thinking about this possibility, and considering the aspect that I did my pre-degree and degree from K College, and as vice principal, you have mentioned, I mean, I am basically an alumnus of K College, and I got greatly benefited during my UG time from all the great teachers I had. So and many of them played a pivotal role in my life. Even the why I went to CUSAT, Cochin University, for masters. there is a reason behind that also. Apparently, my teachers only inspired me, like, okay, you should take up research and you should go in this further direction. So, so that's a great. Great. I'm thankful for that, and I think so. Naturally, my responsibility is to share what I understood over the period of years to my young fellow beings and to all the students. And it's a great program you are conducting. I mean, we have so many participants, and I'm pretty sure they might be expecting much from this title. I mean, we have a very catchy title. So I'll try to convince you about this particular field of astrophysics. And many of my friends or colleagues also might have joined for this talk. And so what my approach during this session will be a very simple approach, in the sense we will be going through some slides, and I'll be mostly showing pictures. And so we won't be talking much of physics or the technical aspects, so that I shouldn't lose audience along the process, right? And so if you have any questions at any point, you can use chat box, and then I'm pretty sure I was informed by the coordinators that there are people who will keep track of the questions, and I will respond to these questions at the end of the talk, right? And also upfront, I'll be happy to help you in any way for further understanding. If you have any queries, you can mail me or message me down the line, because I know that some of the students who did project with me also has joined for this particular session, right? Okay, so one important aspect I would like to be like to explain in the very beginning is Professor Dr. Abdul Kalam was basically an aeronautical engineer. So he is a person. I'll explain to you people how he has been grown up to such a stature, and has built up many the missile facilities, and also sowed the seed for many of the space programs in India. But if you ask me, is astrophysics in a way directly connected to that? I would say it's slightly different, in the sense, in astrophysics, we generally study stars, galaxies, and all those things. But there is a connection when we talk about space programs, because now India is also having a space telescope up there. And I'll explain to you a bit about that also. And in that way, ISRO is basically playing a very pivotal role in launching many of these missions, and thereby helping us to study astrophysics or astronomy. So I'll be using this word astrophysics as well as astronomy interchangeably, so that there is not much confusion in that. But if I go by the exact definition, astrophysics means you will be dealing with the physics aspects, mostly about these astronomical objects, whereas in case of astronomy, it's basically an observation science. So I myself is an observational astronomer, so which means during my PhD time and after that postdoctoral fellowship, or even my students also, they use some of the prominent facilities, observational facilities in India and abroad, and also some of the data from space missions to study about stars and material around stars and all those things. So, and we use different techniques also. So what I'll do is I'll share my screen. So the title for today's talk is why I think this is the right time to do astrophysics. And the plan of the talk is, I will be talking a bit about Abdul Kalam, and how motivating his works are, and on this particular day, why is it important for our nation to remember about him, to think about him, and thereby set plans and goals from a student point of view, also from a nation point of view, right? And then I'll switch to this basic fundamental question: why anybody is interested in astronomy? I think straight away you might be knowing the answer, right? I mean, we'll see. So, and the next point is, so during that session, I'll introduce to you to some of the very interesting objects in the universe. And then the key point, we will discuss why the time is right for doing astrophysics. And so I'll explain and share with you some of the ongoing and upcoming programs, very, very prominent programs, because you see, astrophysics is something like a very key, very important science. I mean, the advantage, people who are working in lab, like for example, people who do material science or other aspects of research in physics, they are dealing with objects, right? I mean, so you are dealing with a sample, you are testing it. So then you deduce things out of it, you get the results. But in astrophysics, we are far away. We are far away from all these stars and galaxies. So what information we are getting is just light from those stars or galaxies. And that's why we should appreciate the cleverness of humans, or because we devised various techniques to analyze this light and see what all things are happening, or how a star is, what a star is made of. I mean, if you think really in detail about these things, it's really amazing, right? Because now we really know what stars are made of, and we also know how stars are formed, and how stars evolve, and also nowadays lots of exciting things are happening about discoveries of planets around other stars, and they are called exoplanets. So some people say it like extrasolar planets. So planets belonging to a star other than our sun. And there are quite a number of them. I mean, every day it's increasing. So last time when I checked, it was almost 4,000 plus planets around various other stars. So this begs the question, are we alone in this universe? Is there any other life form in this universe? I mean, those are exciting things, right? And also about the possibility of, let's say, interplanetary space travel, all those things. I mean, so I think you should understand this aspect, that the closest star to us, which is around 4 light years away, which is Proxima Centauri, and you can also say it like Alpha Centauri because it's a multiple system, and there is a planet available there. So if we are talking about interstellar travel, you're going to another star, and even if you have a rocket which travels at the speed of light, it will take 4 years to reach there. So it's a very, very, very crude possibility, right? I mean, but that thought is exciting, right? And that thought is exciting to see that we are not alone in this universe. And so I'll touch upon a bit of these things because, as you see, these are very diverse, very vast area of topic and study in astronomy. So first we will try to I'll discuss about Dr. Abdul Kalam, and as people who spoke before me, I mean, today is being chosen for this talk because today is the Remembrance Day of Dr. Abdul Kalam. I mean, and as being pointed out in earlier talks, he has lived for this country, and he's a person. I mean, so how I think got familiarized with such a person is through his books. I mean, we all get familiarized with great people through books, right? I mean, and I presume that many of the students who are listening to this particularly UG students, degree students. This is a time to read. So we all got benefited. I mean, I myself got a hold on this particular book during my final year in UG. I remember me and my friend Saju Joseph. So we went to this bookshop and got this book, and I think anybody who reads this book will really get influenced. I mean, because there are lots of, he has openly mentioned about his life all the way from his humble beginnings, how he got into a prominent position as one of the respected engineers in the country. Yeah, so because I still use the word that he was basically an aeronautical engineer. So, and he basically, but he had a huge vision. I mean, so that is what a country needs, even an institution needs, even a department needs that, right? I mean, a vision to think about what will be happening in next 5 years, next 10 years. I mean, so if you go through that book, you will see that Kalam has suggested or proposed about various techniques, such as the re-entry. What he meant by that, it's like reusable spacecrafts. So we know now that the rockets or the space missions, you have a PSLV or a GSLV, so satellite launching vehicle. Once you launch it, and then when the payload is put to orbit, you can't recover or retrieve these components back, right? I mean, so he was suggesting about the possibility we can cut the cost. You have to retrieve all these initial stages which are burning off. You retrieve that part and then reuse it. I mean, that is what basically Elon Musk is doing now. So if you see recent American missions, you see that SpaceX has revolutionized it. And if you haven't seen any of those videos, apparently I suggest you should see that. It's like a miracle. So, but unfortunately for our country, the efforts are going on, and in the coming years, that will definitely happen, because we have proposed for, I think, Gaganyaan proposal is up, and so they are obviously into the path of that, because if you send a person outside, you have to bring him back, right? I mean, so re-entry has to be and something important. So what I'm saying is, this particular person, I mean, so as again, Sir had mentioned previously, Dr. Abul Pakir Jainulabdin Abdul Kalam, that is full form of APJ Abdul Kalam, and he is basically known as the missile man, and that's correct, because he was basically instrumental in developing all those very, very powerful missiles which we are having. Because you see, for a country, along with the development of science and technology, the defense, all other aspects also is important. We have to show our potential and might before the world, right, in every sense. And I think we probably might be maintaining this balance where the science and technology and research is getting very good funding from the government also. So if you see some of his initial days, what you're seeing in this picture is, you can see that in the left picture, apparently, Kalam is talking to Dr. Vikram Sarabhai. I mean, he is again such a legendary person. I mean, so my feeling is, you imagine the situation. There is this country which is newly born in 47, and then when Nehru took over, he identified people at the helm of all the science, engineering, technology, and all, who were later turned out to be legends, and they put all their heart into this. I mean, you name it, Abdul Kalam or Vikram Sarabhai or even Homi Bhabha. I mean, so, and they were positioned at different regimes. Homi Bhabha took care of atomic energy programs, and so we have now prestigious institutes or centers like BARC, TIFR, all these places, right? And Vikram Sarabhai is a person who developed this Indian Space Research Organization. And so there was this mentoring, this support, which many of the young scientists like Abdul Kalam got from these stalwarts, right? So there was a perfect balance of the leaders and the engineers or the people who worked in a team. So they had this feeling, we are doing something great. Because again, if I go back to Wings of Fire, Kalam's book, I mean, you will see that when the mission was a failure initially, how he was supported by his superior. So his boss said like, okay, the media is outside, you don't go, I'll go and face them. I mean, that gives that sort of inspiration and motivation, right? Because your boss is supporting you, your leader is supporting you and saying like, no, I don't want to expose my young engineer to all the criticism. Let failures happen. That's how we build it, build things. And if you look at the right side image, right panel image, what you can see is they have carried these different sections or pieces of rocket by bicycle, and we should be happy and proud of one aspect that most of these initial trials and tests were conducted in Tumba. So, and Kalam has very well explained in his book how this assembly happened there, and this assembly happened in a church, I think St. Mary's Church there in Trivandrum. So apparently the father who is in charge of this church, I mean, he graciously provided that as their lab. And that was one of the so you see all this, such a big organization named ISRO basically had its very humble beginnings. The locality supported them, the country supported them, everybody has confidence in them, and the rest is history. Now the whole world is looking forward. I mean, looking at us. I mean, and every time they hear like, okay, ISRO launched this particular mission at a low cost, and they did like launched multiple satellites. They are very happy. I mean, there is this anecdote all the time, right? I mean, sometimes with power comes respect. I mean, particularly in technological and scientific milestones. When you aim for those things, right? I mean, this is a silent work. I mean, and you sort of build things and go to next level, right? So these two pictures, I thought, basically summarizes the effort and work in the initial phase that those people have done. And another important thing about Dr. Kalam is this is another next book, Ignited Minds, and apparently he may had I think more books after this also, but these two books I think I basically read in the very initial part. I mean, but then it was very much useful. I mean, so he had this dream. Why he loved this? He had great passion and fascination for to motivate kids, and so he regularly visited schools and looked at these all gathering and tried to motivate children, because he was, you see, that is the important aspect of a leader, right? He was thinking like, okay, if I can inspire this bunch of students, at least few of them is going to be getting into some prominent positions in the country in, let's say, another decade or 2 decades. I mean, so there is this aspect, very important aspect. I think our politicians and all people should be thinking, and obviously they are thinking. I mean, when they think about Kalam, I think they will get further motivated. He is a person who thought very much about nation building. I mean, that's a very important factor. I mean, because you see, when I talk about some of these astronomy missions and all, there is always a team which is working for that. And I believe in this philosophy of working as a team. And so if you see our research group also, you see that people work together, people work as a team. And the first thing you all should be remembering and keeping in mind is you should give out your knowledge and share with people. The more you share, the more rich will you become. So so that is very much important, and there is no point in hiding things and doing a solo exercise. I mean, so it's all about a collective effort. And then he mentioned like you dream, and you not only if you keep on dreaming about things, this is like your teachers. I mean, if I'm so basically all throughout the talk, my intent is basically to address the most youngest person attending this meeting. So I wish to see that there should be a focus, and there should be a motivation, and you should be having a target in your life, so that you should do this. I should achieve this, right, in a very positive sense, and keep working for that. So that's what he had said, right? And dreams can transform into thoughts, and the thoughts obviously should result in action. And also, there is another interesting thing which he has mentioned somewhere, that you do keep on doing hard work. I mean, and also he mentioned like, have you heard about anybody who died of working so hard? I mean, in the sense, if you imagine like, okay, I'm going to study more harder, try more harder, and obviously that will enrich you. And that's something very important, right? So I conclude this discussion about Kalam from this slide, and this is a couple of the positions, something bit about the positions he occupied in various forms in the government and in DRDO. So he was the Secretary of DRDO in a very prominent position, also scientific advisor to Prime Minister. And he was basically instrumental in conducting nuclear tests in Pokhran. And later we knew that, we all know that he became the president of India. And he was known as like a people's president, right? I mean, he was very humble, always lived with minimal facilities, and such a great life, right? And also the take-home message for you people, I should say is, there is this person who had very humble beginnings, because he is like a very minimal, he belonged to a very minimal family, not have much things during his childhood. But then he realized that, okay, if I put all the effort, study hard, work hard, then I can follow my passion. And he had this initial passion being ignited by his uncle. So, and you see that there is always, if you have this passion and interest for something, I have this belief that there is always somebody who will be playing a pivotal role in your life, orienting towards that passion. I mean, so that's where people used to say the nature conspires to get things done, right? I mean, so only thing is you should be having that commitment and dedication and passion for something, right? And so also he made this wonderful quote, I mean, that dream is not that which you see while you are sleeping. It's something that does not let you sleep. So I think if you ask any researcher, including me, I mean, so more than the technology, so I'm talking from my personal point of view. If I to talk to my colleagues or students, they all agree with this aspect. If you are working on something, and if you're thinking about something, we may have lost sleep over a period of time. I mean, what I'm saying is like a research problem. And so we used to, so that's how ideas, if you keep thinking about things, that's how ideas comes to mind. And that's how you do research, you discover something, and you get an interesting publication all the way. Okay, so I'm also thankful to Gaurav Banerjee, who is my PhD student. Apparently, he had given previously a talk on Abdul Kalam, and he had sent me those slides, thinking that I'll be giving a full-fledged talk on Kalam. But so I have included a couple of few points on that. Anyway, so when I remember when I attended his talk, so all these are like memories which is staying. So when you read a good book, that's how I realized when you read a good book, As I said, I read during my UG time, right? I mean, after that, I haven't touched it, but still many of those anecdotes stay in my mind. And this was like a trigger. I mean, because when somebody present this, you happen to see, yeah, I know. Yeah, these things were in his book. I remember. Clearly, it comes like something is revealed to you, right? I mean, it's a wonderful feeling. So, right. Now, we get to the next section. So if there is any delay in the slides or anything, please let me know. If you are not seeing it, coordinators can interrupt me any moment. But others, if you're having questions, always use the chat box, right? I mean, so, okay. So now the interesting aspect is why anyone gets interested in astronomy. So if you ask that question yourself, and if I ask you to say an answer, I know there will be lots of answers, but astronomy is always driven by pretty pictures. I mean, because you see the picture which I have shared is basically an interacting galaxy. It's one of the very wonderful picture which I thought, I liked it very much. So you see that there are two galaxies which are interacting. When I say galaxy, you have to see that all those tiny dots which you are seeing in there are stars. So the basic idea here is for every galaxy, there is something like 100 billion stars. And so there are lots of zeros involved. And if you look, if I convert these to our jargon of crores, you might be now knowing about crores, right? Crores of rupees, and we are hearing lots of stories. And so if I convert to that, this comes to like, let's say 1,000 crores or 10,000 crores, something like that, right? So lots of crores of stars, right? So, and you see such a monstrous galaxy is interacting with another neighboring galaxy. Possibly what I can do is I will be using a pointer also, if you can see my pointer. So this will lead you in further when I say. Now onwards, I'll show pictures, but then I will tell you some interesting stories also connected to that, which you may not be seeing. You will be looking at the aesthetic part of it. I will be explaining to you the scientific part of it. So I'll tell you, like, there are lots of stars here. New stars are forming, particularly in the region where the interaction is happening. So you see that there is an extended layer here, and presumably connected due to this particular interaction. So galaxy contains stars, gas, dust, all those things. When I say gas, mostly hydrogen, helium, all those things, right? So these pictures, I mean, so if you search in Google, you will see lots of pictures. Or even if you are at a very good place, I mean, far away from the city, and if you are not in, and that too not in rainy season, if you look up at the sky, particularly December time, that's great, right? I mean, I'm pretty sure many of you might have gone to the terrace of your house and looked up and stared at the stars and wondering like what they are, right? During your childhood even, I mean, because nobody knows what stars are at that time, right, apparently. And so that's why people from all streams and walks of life love astronomy. So if I used to happen to meet randomly people, so I know that there are professionals who are in banking sector and different sectors. Apparently they had this huge passion for the field, but their career is something else. And but then they follow all these discoveries and interesting things in the field. So I would say this is more like a citizen science. Anybody can read about this, try to understand. I mean, today we are not talking much about technical things. So I'm going to make it simple for you so that all of you should look into this and follow this for your happiness. Okay? So that's the word I use. So let's look at another picture. And this is taken by Hubble Space Telescope. I think all of you might be familiar with this. Apparently, Hubble observed one particular region of the sky, and it observed for multiple times in various orbits. So what you see is basically a stacked image of different frames. So it's like, imagine like you are looking up in the sky in one particular region, staring at it for loads of time, right? And what will happen is things start to get clearer and clearer to you, right? I mean, obviously, that's a very nice way of saying it. But telescope, what it do is, if you make it stare for one particular region of sky for some time, it starts collecting light. That's what telescopes do. Don't do any magic, just collects light. And if you can add such, so it's like taking a photo, integrated, exposure. So many of you might have used a camera. Increase exposure time, take a photo. Similarly, take another photo and add something like thousands of such photos. Add together, you will increase the signal. And that's what you're seeing here. Apparently, most of the things in the frame are galaxy, almost all of the things. And they are very, very far away from us. I mean, we are talking about millions of light years away from us. And all categories of the galaxies are there. I mean, such a beautiful picture, right? And apparently, if you are listening to this talk and sitting in a very dark room, and then you can see these images as really stunning. So, yeah. So next point is I'll introduce you. So I'll be showing representative sample of different galaxies or interacting galaxies and all, and so that to motivate you, and you should go and search for further things, right? Now, what you are seeing here is two images. One is one image which is there on the left, which is basically taken with the optical telescope. So this is something visually you see, right? And the zoomed in portion of this image is shown in the right, which is taken with ultraviolet. So this is something interesting which astronomers do. What we do is we use telescopes like a binocular. You can think about telescope as an expanded version of a binocular, and and collect light. So our eye has this sensitivity limit, which means you can only see very bright stars up there in the sky because the lens in our eye is very small. So instead of that lens, we are making a very big mirror, and the diameter of the mirror mostly is like 2 meter, 4 meter, and all, which is something which is available in our country. We are using that for our professional research. And but now I'll talk to you about some big facilities which are coming up, where the mirror size we are talking about is the diameter of the mirror is almost like 30 meter, even 40 meter also coming up. So that's exciting, right? And that's not a single mirror. It's like a multiple segmented mirror and all. So that's a scenario about optical region. So we say like optical and infrared. And so if you know about various wave bands, this is a composite from ultraviolet region. Now the question is why I want to observe. And in order to observe in ultraviolet, what should I do? You should, that ultraviolet don't penetrate through the atmosphere. You have to send a space mission. So there is apparently India's space mission, which is called Astrosat, which is having a payload which observes in ultraviolet. You send it up in the atmosphere, and so it will observe all these. It will look into these. So most of these blue stars which you see up there in the sky, they are emitting in ultraviolet. They are very hot, because you might be having this notion, right? I mean, blue color means, oh, it's a bit cold. I mean, it's comfortable because you think about a moonlit sort of night, and you see that it's blue hazy night and it's very cold, and that type of feeling. But physics, you ask any person who studied physics, they will tell you blue corresponds to hot. And if you are not agreeing with this, you look into your gas burner, which is there in everybody's kitchen these days. You see that the most hot region in the central region is shining, that's burning in blue, whereas the outer region is burning in red or yellow. So don't try experimenting on that, but take my word for granted and believe that blue is the most hottest thing. And if we have relations like Wien's displacement load to calculate, if I know the color, I can calculate the temperature. So that's where we are getting into equations. So let's not go there. But you have to believe me when I say that our sun is of surface temperature, sun is having a temperature of, let's say, 6,000 or 5,500 degrees Celsius, when I say that the blue stars which you look up in the sky, when you see all the blue stars there, next time you should remember that the temperature is around 20,000 or 10,000 degrees Celsius. It's far, far hotter than sun. And we should be thankful to Mother Nature that instead of our sun, if one of those blue stars were here, none of us would have been here. So that's a thankful sort of thought, right? I mean, everything is in place, our solar system. Things are in very comfortable place. We are having a great life, and we are not worried about like, okay, will the sun switch off sometime or other? And if you ask any astrophysics person, he will say, no, don't worry. I mean, sun will burn just like this and provide us heat and light for another crores and crores and crores of years. But then there is a quite possibility we as a race, humans, trying to make our life impossible, right? I mean, so we are good at polluting the planet, and we are good at making different issues. So we are seeing change in climate due to many of these things. Okay, so if I come back to this topic again, I'll show you a couple of more pictures. I mean, so something which I showed you earlier was mostly like galaxies. Now you see some stars. I mean, I think all of you might be familiar with this constellation. Where my cursor is going, I'm just going around that constellation. And this is basically called Orion. And we say like Orion the Hunter. So this belongs to the shoulder of Hunter, and this belongs to the belt, and this is in the knees, and the Hunter is having a sword. All those, though these are constellation, means it's like a pattern which is visible to us. And that doesn't mean that any of these stars, most of these stars are not at the same distance. They are at different distance, but from our vantage point, it appears as if like some pattern. So the Greek and earlier astronomers, I mean, if you see the whole initial phase, if any of you have read about the way science was built up based on philosophy, reasoning, the Greek philosophers have played a great role, right? I mean, so or even Babylonians, even Chinese, and ancient Indian astronomers were there. So every culture had that role to play, right? So that's how many of these constellations were named, and they ascribed it to mythological characters, right? I mean, from this science point of view, if I make you familiarize with some of these stars, I mean, let's focus on this particular star, which is looking like totally different color, right? I mean, so this is called Betelgeuse, and it's basically sort of like technically, if I say this is a red supergiant, so it's a supergiant means it's like a very big star, okay? And that's expanding, that star is expanding, and it may explode, let's say, in another 100,000 years. So obviously, none of us will be there, and we will be in this planet at that time. And I'm not quite sure whether our planet itself will be there by that time. But let's be positive and optimistic and see that if another race is here or humans still continue till then, you will see this as another bright moon there in the sky. So this is like two moons in the sky you'll see once this explosion happens. So apparently, if you read the latest studies on this star, it has gone through brightness changes, and there is a possibility it has gone to another stage in the evolution. So Betelgeuse is extremely interesting star, and similarly, we can. That's the most interesting. That's why I want to focus on that, and I will be talking to you minimal things because the idea is not to confuse you through this talk, to motivate you and share with you some of the wonders we have in the universe, and particularly in our near neighborhood. I mean, these are like near neighbors. Although when I say near neighbors, the distance to these stars is almost like we are talking about, let's say, 800 light years or so, 800 or 1,000 light years. I mean, that's so far, 1,000 light years. But then you can see it, right? I mean, if you can see very clearly, that's near for us. Yeah. Now, the right image, the image which is shown in the right panel, is basically a zoomed in of this particular region, and that is termed as Orion Nebula. So you might often hear this name nebula. Nebula is a region where the stars you see quite forms, and you can see lots of stars, newborn stars here. So lots of stars are being formed here, and the technical word for these region is they are clouds. They are molecular clouds where hydrogen is present in molecular form, and all those things, right? But in popular literature, you see that the different patterns. I can if you search in again in internet, you will see lots of nebular pictures. I mean, very interesting pictures. As I said, these pictures basically motivate people or make people interested in astronomy, right? Okay, finally, we have to, if I show all the images and forget our sun, that's not a fair thing, right? I mean, so, and if I tell you I'm showing an image of sun, or it's like a GIF file, so you see slightly like a movie of sun, I don't know how many of you believe this is real sun. So what sun we are seeing every morning or evening throughout the day, when you look up, it's very peaceful there. I mean, sun is not doing anything troubling us. It's just remaining there and making us aware that, okay, everything is going well. And so that's interesting. But what image you are seeing is basically taken in ultraviolet again. It's not in optical, using this NASA's facility, which is called Solar Dynamics Observatory. And what features you are seeing here is you have sun is basically like a plasma ball, right? I mean, you can see that lots of gas is there. And you have magnetic field there, like in the case of Earth. Earth, we know that magnetic field. Similarly, in case of sun. So what happens is that's why all these features are happening if you follow my cursor. And here also outburst and things are happening. That's why this spark is happening, which means there is this material, plasma, which is, imagine just gas coming out of the sun, or charged particles flowing out of the sun, which is being guided by magnetic field. And sometimes it look like a looping going back to the sun itself. Sometimes it will be thrown away. If lots of charged particles are being thrown away from sun and gets into our atmosphere, Earth's atmosphere, because we also have a magnetic field, and the sun's magnetic field can get connected with this our magnetic field. And you can imagine it like you might have gone for this ropeway, right? I mean, and you see that one end from one mountain to another mountain, you go by ropeway. Similarly, the charged particles are being guided by the magnetic field, so that some of them enters through to the Earth's atmosphere also. And how do we know that? There are something called northern lights or even southern lights. In the polar region of Earth, you can see in the upper atmosphere these light flashes. And that light flashes are because the charged particles gets into our atmosphere, and the gases which are present there, primarily nitrogen and oxygen, basically they ionize and they emit. So the color is due to these gases which are in our atmosphere. So it's letting us know in a way that, look, I can be harmful also, right? So, but anyway, we don't have a role there. I mean, as I said, we have a role in maintaining our planet, but we don't have a role in seeing like what's happening to sun. That is entirely to do with the evolution of the star. And there are people who are really looking into, there are many space missions. So I'm showing you right now is a movie which is made by the space mission, Solar Dynamics Observatory of NASA. So there are many active missions which are happening now, right? Okay, so now I'll get to this point. What I think, why I think basically this is the right time to do astrophysics. The reasons are listed here, right? And I'll try to explain this further up, because there are lots of big projects. I mean, for a person who is doing PhD or even doing masters now, by the time you graduate, and many of these projects will be in the very advanced stage or almost in the first light stage. So we will talk a bit more about these projects. So I have just included some representative sample of TMT, SK, JWST, etc. So I'm trying to include different bands also, starting with optical astronomy, infrared astronomy, radio astronomy, all these different branches. And another important aspect is there is lots of archival data available. So many of these space missions and many of these telescopes, the moment they start observing stars and galaxies, they are making it available in open databases. So anybody can take that data. And even recently, my students also have published very excellent papers in very competent journals using this data. I mean, so you can really do research through that way. And also, I want to touch upon some of the advances which is happening in field of exoplanet research. Why I thought I should discuss touch upon a bit of science part also. That's why, but not much technical. I'll keep it very simple. And so I'll talk about exoplanets. And why this is tied up to this question is there are big projects, there are studies about exoplanets, and also there are these new research fields which are coming up, because you know about the discoveries which is happening in the field of gravitational wave astronomy. And also there is some interesting field called astroseismology, where people are trying to see like vibrations from the stars, trying to understand the vibrations from the stars. So I won't be going into these new research fields because that itself will take another talk, and also I'll try to touch upon these first three aspects. Right. So in order to understand that, let's try to, I'll introduce, again, I'm just touching upon very few different aspects of the very famous ongoing ground facilities as well as space missions. The first one is ALMA, and ALMA is known as, that's the full form is Atacama Large Millimeter Array. So you have these radio antennas, which is collecting radiation in millimeter from all the different celestial objects. Because you have to understand that when you look up at the sky, you're seeing only in optical, you're seeing only in visible light, right? But there are objects which can, which emit in infrared. There are regions which emit in millimeter, in radio. And if in millimeter and radio, particularly radio, we can observe some windows are only possible to observe from ground. We can observe in optical, in radio. These windows are particularly open, slightly in the near infrared also open in ground. But many other windows, like if you are looking into high energy window, you have to send space missions, right? And also atmosphere can be like a turbulence issues are there. Atmosphere can be like tricky, and it can distort or worsen the quality of the images. You see stars twinkling, right? I mean, the basic idea is turbulence of the atmosphere. That's like the reason. That's the reason, right? So in order to get rid of that, you have to send telescopes up. So not only for high energy missions, for optical also we send telescopes. And I showed you these Hubble Space Telescope images. They were basically, most of them were observed in optical only and slightly. So so you will get crystal clear images. That's the whole idea. So this ALMA is a series of observatories, a series of antennas which are lined up there in Chile and Latin America, South America. And Chile is a very favorable place or interesting place or loving place for astronomers, because it's mostly stationed in close to Atacama Desert, because astronomers are a species of people who love to be setting up their telescope where no human settlements are there. So you see most of these telescopes are far away from the city lights, in some jungle, some desert, even in some islands where no others should be able to come. That's not a selfishness, but then we are looking for to see, get a very clear view of the sky, and so that's something very much important, right? So and so it's great. It's an ongoing the facility. I mean, lots of studies are happening, lots of discoveries are happening using ALMA. Then we get into AstroSat, India's multi-wavelength space observatory, first one. I mean, obviously, as I said, ISRO launched it. After that, the scientific institutes, IIATI for all these people, had their payloads in there. They study different objects in X-rays, ultraviolet. It's still orbiting. And apparently last week there was this proposal call. Every year they're calling for proposals. So in future you also can apply. So there are interesting things happening with AstroSat. Lots of applications coming out. Yeah. Now the next thing is two more missions I just want to show. One is Kepler, and Kepler has done remarkable advancement in the field. When I talk about exoplanets, I'll say a bit more. And then there is another mission called Gaia. Okay, so why Gaia is important is it's very hard to how will you measure distance to a star? I mean, it's very tricky, very difficult. And that's where we use some concept called parallax measurements to study the distance to the stars. And the Gaia is going to provide us with accurate distance measurements of millions of stars. That's a target Gaia is having, and it's doing a wonderful job. So many of these things are moving up there. I mean, so and doing a perfect job, and it's giving out data and keeping it in databases. And now there are I don't think not much astronomers around throughout the world to look into much of this data. So everyone can look into that. So and so this is the point I was making. I mean, so lots of this data is available in public database, and we don't need a lab. We don't need much other things to do research in astrophysics. You just need a computer and internet connection. And obviously, I'm not making it very simple for you, but you have to understand and appreciate this aspect, that fundamental understanding about physics and basic training in astrophysics. All these things are needed. I mean, because you have to identify when you see a data and somebody has listed something called magnitudes for you, and they showed some image and told you like this much is a flux coming from that particular region. You need to understand what those quantities are, right? But otherwise, that's the training which is needed to do research in any field. But so my feeling is anybody can do research in astronomy. Anybody who is having a motivation, willing to learn, and so we don't need much big facilities and all. That's an advantage. And but also, we know of people who are doing great deal of things. I mean, there is something like citizen science projects. You can search for something called Sooniverse and all, which is happening in different fields, because you will be given, this is being conducted by professionals. I think the basic idea of Sooniverse was by somebody named Chris Lindot from, he was in Oxford. I think now you went to US. I mean, but there is a huge team of people who is behind this idea. So if you log into that, you will be given training on classification of objects and all. And then you can see real data. And then in some cases, you see, particularly in US and all, there were people who were working in different sectors, like in IT sector, in banking sector. And after their job, they come back home and they spend every night a great deal of time doing the classification, learning this and all. And some of the luckiest among them, luckiest in the sense, some people who really contributed to the classification and found some discoveries, they got their name in a research paper. I mean, so imagine the thought. I mean, so such a thing happening, right? And that's again a more benefit-driven thing, right? But there are a great deal of selfless people, extremely selfless people, in the sense amateur astronomers. I mean, throughout the world, you can see. I mean, there is this interesting joke which is being circulated all the time that if the climate is not that great for over a period of time in any part of, during some part of the year in Japan, there is a high probability that the people who work in Norway means when a star explodes, you will see that as a bright object in the sky. So so if you look at previous images of that part of the sky, you don't see a star there. One particular day you see a star there. I mean, who will detect such discoveries? Only people who are looking up at the sky every night. Why are they doing? Are they getting funded or paid for that? No. And they are doing it out of passion. And once they discover some of those things, what will they do? They pass it on to professionals. because what they know is the detection part. They don't know how to do the science part. So, but then the professionals apparently support them in the sense they include their name in the in the publication and all. So it's basically a symbiotic relationship, or it's like a collective. So that's why I was telling, like, astronomy or any lead science is driven by groups. And you look at gravitational wave discovery papers, there are hundreds of people associated in that. So that's important, right? Now let's look into future. I mean, future missions. It's exciting. I'll touch upon few. I won't take much time. I think I can wind up in, let's say, 5 minutes or 6 minutes. I'll try to make it fast. Okay, so one prominent mission is one prominent telescope which is coming up this decade possibly is 30-meter telescope, which means it's a big telescope. Imagine that, which is having a single, which is having a primary size of around 30 meter, but then you see that it's multiple mirrors making up a single mirror. So we don't go to the technical details, but the idea is why we are making this big telescope is we would like to see the first galaxies and first stars which are formed in the universe. Because if you imagine, the age of the universe is around, let's say, 13.7 billion years. I said billion. Billion means it's like 1,000 million or 100 crores. So you can scale it and see it. So universe is pretty old. And so we need to study all those objects. Yeah. So, and in the radio regime, there is this big project which is coming up, which is called Square Kilometer Array. So imagine a huge field full of radio telescopes, small radio telescopes, and they do this interesting aspect of combining beams from different telescopes, something named as interferometry. And you all know about Michelson interferometry and all. I mean, so if you're interested, you can read through it. And another very ambitious mission is James Webb Space Telescope. I mean, this is going to replace Hubble because Hubble has grown old. I mean, that's a mission needs a replacement. So JWST is something there in the pipeline. It's mostly going to look into exoplanets, right? I mean, lots of discoveries we are expecting to happen in future. That brings me to this final topic, which is about exoplanets. And what you are seeing here is a planet. This is a cartoon, basically, of a planet transiting in front of a star. And the idea is, so you are seeing a curve which is happening. So if you see the brightness of the star just like this, brightness is remaining. Once this transit is happening, brightness will dip. And once the transit is finished, it will get back to normal. So there is this Kepler Space Telescope, which I mentioned to you previously. That Kepler telescope, what it was doing is, it just stares at one patch of the sky, one particular region of the sky. And it just looked for whether any star is dimming. I mean, that was the whole idea. So it collected the light from the star and monitored this light over a period of time and found that and just checked whether stars are dimming. And interestingly, because there were initial suspicions. I mean, if you're just looking at one patch of sky, how come you possibly can get such a dimming thing? And you see, and when the mission progressed, they start detecting planets. And this method is called transit method of detecting exoplanets. And along with transit, there are many other methods. Prominent 4 methods I have listed here. And there are space missions which are looking into this. For particular transit, there is this Kepler. And Kepler is almost done with the mission. Last many years, it has done a great scientific productive dividend it has given. And now there is another mission ongoing, which is called TESS, right? But you need to understand that how people cleverly look into this light curve. We use the term light curve for this. And from this, we can estimate the radius of the planet and even can calculate the density of the planet. And through some other clever methods, you can get the mass. And now there are missions which are trying to retrieve the atmosphere of the planets, right? I mean, so how clever people have become. I mean, as I said in the beginning, you're just collecting light from a star. I mean, here, not even from planet. I mean, planet won't emit. star only emit. So if you just imagine a source of bulb, and you try to block it, you will get less light, right? And if you see something moving around that source of light periodically, you will see that this pattern will be appearing periodically. And that dip in the light, if you see the cartoon, you see that dip will be more if a very massive planet passes in front. That's how you get an idea about the radius, right? Okay, so there are very distinct categories apparently. So if you look in the planets, there are hot Jupiters, which means planets which are bigger than Jupiters. We were in knowing this. We were happy with our solar system, right? We were happy with Earth or the rocky planets in the inner part of the solar system. So when we say rocky planet, it's like Mercury, Venus, Earth, Mars. So after that, beyond Mars, so you have Jupiter, Saturn, right? Jupiter, Saturn, Uranus, Neptune. That's it, right? Jupiter and Saturn are basically called gas giants, right? And whereas Uranus and Neptune, they are called icy giants, more like icy. And Pluto is not in the list anymore. We all know that, right? So, but we were of the impression that that's how the other planetary systems also should be, because some stars were found to have multiple planets. But this is a histogram which I'm showing out of the planets which were discovered by Kepler. This is slightly old, the plot, but then if I don't know whether any of you realize the surprise here. And so what is plotted here is we have 808 Earth-sized planets, we have super-Earth planets, we have Neptune-sized planets, Jupiter-sized and all. And most of the planets apparently belong to this category, right? And they belong to something called super-Earth, or even something called mini Neptune, which means slightly bigger than Earth and slightly less than Neptune. And if you think, or if you check your knowledge about our solar system, you know that we don't have any such planet which is bigger than Earth and which is smaller than Neptune. So what were we feeling so proud about all the time? We were thinking there is only life in this planet, and our solar system is very special. There is no other star with multiple planets around it. Now people have discovered there are systems like TRAPPIST, which is having multiple planets. And then the important aspect to us, okay, our the planetary distribution is perfect, but then that also turning out to be wrong. We are like an outlier right now, because most of the other planets which are discovered, most of them are either belong to super Earth and mini Neptune category. Also, there are hot Jupiters, right? And also there are many more interesting results which is coming in exoplanet research. I just don't want to go into too many of these things, but then you should be having this take-home message that most of the planets which we have discovered around other stars are belonging to super Earth and mini Neptune category, which means we don't have such a thing in our solar system, right? Okay, so there are many upcoming exoplanet missions. The huge list is here, and ground-based facilities also following it up with. So nowadays we can cheat the atmosphere through ground-based observations, which is called adaptive optics observations and all. So if you're interested, look for it. So these are the concluding remarks. And I think astrophysics should be like a way of living. I mean, so I will make it simple. Let's forget the fact of it. So some people during your grad UG days or initial days might not be a huge fan of physics. Okay, then that's fine. But then I'll change this to astronomy. Astronomy is an observational science. And in order to understand the secrets which galaxies and stars are hiding, we need to have a good understanding of physics. That is obviously needed. But in order to appreciate things and enjoy things, you should be having an aesthetic sense and aesthetic mind. And for the students, I recommend you should be having good skill set. Anybody will employ down the line, because there is this huge field of data science and all those things coming up. And if in the degree time, in the very young age, you are having skills in programming languages, and data handling tools. That will be really good, and that take you forward. I mean, so, and also I think many of you should be in future be part of many of these interesting observation campaigns, because when I say observing programs means there are all these big facilities and upcoming facilities, they ask for proposals. You have to write a proposal to them, ask them like, look, I want to observe this object, and you have to explain why you want to. And that needs a bit of hard work, expertise, and smartness. And you have to publish papers, research papers. So it's a hard work altogether. I mean, and astronomers in general, if you are doing observation, you don't sleep at night. And if you want to sleep in morning after that, there will be some research problem or something lined up so that you may not sleep then also. So life is going to be hard if you take up this, but then it's worth it. Okay, so thank you very much.
Thank you, sir, for your wonderful words. It was very informative and thought-provoking. We are looking forward to have more and more lively sessions from you.
Yeah, thank
I
you.
would like to remind all of you to make use of the chat section here to post your questions or doubts to be clarified with our guest, Dr. Blesson Matthew.
Yeah,
We have questions
thank you.
from Agil
Yeah,
Krishnan.
sure.
Sir, what is the main difference between astrophysics and cosmology?
Okay, that's a good question. I mean, because there is this confusion all the time people are having, like, let's say, astronomy, astrophysics, cosmology, and all those things. Cosmology, in a broader sense, it's studying like universe at large, because people will be studying about galaxies and how galaxies formed initially, how the universe formed, and you talk about, you might have heard about Big Bang, and all these different aspects, right? I mean, it's like a bigger scale, right? And when we talk about astrophysics or astronomy, I would say there is a distinction. Astronomy is like an observing science. You mostly talk about like any stars or objects which are visible in the sky through your eyes. And astrophysics basically have this different. So if you go for any meeting or if you look into professional talks, you will see that any session in astrophysics will be split up into various categories, like, let's say, solar astrophysics, stellar astrophysics, cosmology, general relativity, all those things. So it's just a naming convention and studying different classes of objects. And that's all. Don't worry about these things. I mean, because if you look into that, I mean, there are many interesting things in astrophysics, which has some trick with the namings. So that's all.
Sir, another question. Can
Yeah.
quantum mechanics have any role in astrophysics?
Yeah, yes. Why do stars shine? I mean, why our sun is burning? I mean, so quantum mechanics plays a role. I mean, so because if you look into, so what is happening there inside the sun is a process which is called nuclear fusion, where you are having the hydrogen atoms. Exactly, it should be protons. It's like an ionized region, right? So let's think simple. Hydrogen atoms or protons combining to form helium nuclei. So if somebody tells you a positive charge particle and another positive charge particle interact together and form another particle, nobody will believe, because you say that no, it repels. But then why is it happening? Thanks to quantum mechanics. Because it's not that you should understand that quantum mechanics is not telling, okay, do it this way. But there are some interesting aspects where which works in the particle regime, which is basically called quantum mechanical tunneling processes, and due to which you will be having this fusion process happening. So yes, so that's why when I was doing once you join for PhD, in general you have a coursework program in institutes. So during my coursework program, my professor told me, like, be proud to be an astrophysicist, because you have to learn everything, not only physics, sometimes chemistry, sometimes biology. Apparently, one of my students is learning chemistry for his research. I mean, he knows, I think, more chemistry than me by now. So yeah, so sometimes you should be open to learning lots of things. Yeah.
Thank you, sir. Sir, I have a doubt. Sir, you mentioned Betelgeuse. Is Betelgeuse going to explode?
Yes, that's what I was telling. It will explode as a supernova one day. and that one day will happen, let's say after probably 100,000 years. I mean, because we have only models, so prediction is very difficult in astronomy. So from the present set of models, people expect that it can happen. Some people say like 10,000 years, some people say 100,000 years. Anyway, it's not a matter of worry for us, because we are talking about 100,000, 10,000 years, right? I mean, but that's what I was telling. If we happen to see that moment, that will be wonderful, right? Two moons up there in the sky. It almost shines like a moon there in the sky. So that will be a wonderful thing. Somebody asked about Aditya L1 mission. Yeah, that's a solar mission apparently, because you see many of these images which I showed, I mean, a couple of images which I showed about sun, they are basically mostly from NASA missions. Apparently there is this Indian mission which is lining up and to study the sun, and it's called Aditya, and Aditya is similar to the word for sun, right? I mean, so I think you will hear the news down the line, and and keep track of it. It's a very interesting thing. People are looking for that, and yeah. So any other question? I can see
Yes, sir.
another question. Yes, dark matter plays a role in star formation. Yeah, okay. So basically, in the broader context of structure formation in the galaxy and all, apparently dark matter plays a role. I mean, we have evidence for that. But in the star formation scenario, people suggest, have propositions, and there are my friends and colleagues who are working on that, who suggested that. But observational evidence, we yet to have that. But I haven't touched upon this aspect of dark matter and dark energy at all. And to all the audience, I would like to say that our knowledge is very less about all these things, very limited. So that keeps us very humble again, right? I mean, the all visible, measurable matter in the universe, which we are seeing, all these galaxies, stars, everything, just account for 4%. It's just 4%. The remaining 96% we don't know much about. And so that includes dark matter and dark energy. So there are lots of studies happening in that direction. Yeah, that's right. And so there is a question about the difference between space-based astronomy mission and other space missions. Okay, so when you might be following this news, like most of the ISRO missions, ISRO missions are like, let's say, communication satellite or remote sensing satellite. They are nowhere related to astronomy. Only astronomy mission which ISRO sent till now is AstroSat. I mean, that's totally for studying stars and galaxies and all. Otherwise, every country has its own communication satellites, all these things. So once you send up a satellite for astronomy purpose, it's basically totally devoted for that, right? Yeah. So there is this technical question, I think Shruti probably asked about dynamical equilibrium in astrophysics. I don't know in what context you asked. I mean, because this particular equilibrium is being seen in different phases in star formation and in various phases in structure formation and all. So I don't know, but it's almost like an evolving sort of. It's like you can say mostly like a hydrostatic equilibrium if I bring into the context of stars. So I would, yeah, sure.
Sir, how exoplanets are discovered using radial velocity? Do dark matter play a role in star formation?
Yeah, dark matter, I already addressed that question. Exoplanet through radial velocity. Okay, so the idea here is, imagine you are having, like, there is this bound system, right? I mean, the star and the planet. So the planet is moving around, and what will happen is the star is emitting light, and that light we can split up into different spectral lines. In the sense, I can observe these different spectral lines. So there is this technique in spectroscopy. So you see that due to the influence of the planet, the spectral line will shift, and we measure that shift in wavelength, and from there you can calculate the radial velocity. So if so I am intentionally avoiding technical things. So just imagine that the light from the star is split up into various wavelengths, and there are various spectral lines, absorption lines, which are coming out of the star, and you see the shift in the line, and from that you can calculate.
Sir, what is the advantage of having programming knowledge in astrophysics, and could you explain about the other field of physics that we should master in while we pursue astrophysics?
Yeah, because programming is really important and good for all fields of physics, I think, because nowadays you can't sit somewhere and say like, look, I'll work in lab and do this experiment. And if you really want to become competent, you should be having skills. We used to use the term skill set. I mean, so your opportunities, you are expanding your horizon, right? I mean, so tomorrow, when the people will ask you, they demand you for job, right? I mean, so you needn't have to search much for job. I mean, so if your skill set is really good, so don't go randomly and learn umpteen programming languages. Nothing of that sort is needed. I mean, these days people are using Python in general, particularly in astrophysics and various aspects in physics also, I think. So learn that there are lots of tutorials available online. I think even students in my group, I mean, starting from the masters and PhD students, all these people, they started from the very basics. They were in knowing. Now many of them are very good experts. I mean, they can write codes, and so it happens only through this openness. I mean, we should keep this feeling away that yeah, I don't know things. Somebody teach me. I mean, beyond the curriculum, everybody might be tied up with these things. I mean, there is this self-learning process which should be going on, right? Yeah.
Sir, what are scopes of archaeoastronomy in India?
Okay, archaeoastronomy. Yeah, I don't know. I don't know about the job prospect or anything in that direction. I mean, but I know of like some senior astronomers had had done lots of studies in that direction, and trying to, for example, we have solar studies. Many of the solar studies, people used to talk about Konark, Sun Temple, and all. Yeah, so there are various interesting things. I mean, but if you're asking from the context of a job prospect and all, I'm not sure about that.
Sir,
And for that matter, don't think in terms of job prospect or sense, because I don't want to drive. That's why I didn't touch upon when I talk about skill set. Also, I was trying to tell you that you that should be a total growth of a person, right? Wholesome growth. That's what I was aiming at. And so, if you're good at what you're doing, people will ask for you. I mean, will offer you job. So that's the feeling I had. We all had. My colleagues had. And that helped us. I mean, certainly.
Sir, is there any chance for Betelgeuse being a variable star?
It's a variable star already. It's a variable star. It's varying in brightness. If you see the recent news reports which came up last year, you will see that it's dimming now. Its brightness is going down. So people are now suspecting that it's getting into next phase in its evolutionary channel. So after Sun finishes this nuclear burning stage, it also goes through different evolution phases. Sun will become a red giant, then will explode, then the core of the sun will become turned to a white dwarf, and all. I mean, but that will take that will happen only after billions of years. So we are safe. So, but then when the sun expands as a red giant, apparently nothing can survive on Earth because the temperature here will shoot up. Yeah.
Sir, a good question from Renuka Velu. How to use these lockdown days more effectively to broaden our knowledge in astrophysics?
Good question. So there are these online courses, I mean, which our students also doing. I mean, we have requested from the department our students to take courses in Coursera. And so there are various online platforms where you will get free courses. And in our case, our university is having an account through which the students are able to take paid courses also. But otherwise, for common people, there are lots of online courses. The other day, I saw in newspaper about two students, who took online courses and learned lots of things. So there are lots of courses offered in astronomy, in Python, in programming languages, lots of things. So if you take up a course, that will generally span over, let's say, 1 month or 2 months. You can take at leisure. So, and I don't encourage. I don't think you should go for paid courses. But if you can manage that, that is also an option. But there are lots of free courses and lots of lectures, online lectures. Even we, for example, we also teach, right? So if I want to teach any topic, so my classes will be starting next week. So I go through online lectures. There are lots of brilliant lectures out there. So information explosion is happening.
Sir, which country is great to do research in astrophysics other than India?
Yeah, so my feeling is the facilities come secondary. So if you are in US or Europe or anywhere, so what I tell my students or what we do is, if you are able to publish a paper in a reputed journal, because when you send research paper to a journal, they don't just accept that like that. It undergoes a rigorous referring process, which means it's sent to an expert, and they will assess the quality. So many of our students, they have very good publications in extremely competent, good journals. So the question is, many of my colleagues also do that. So if you are doing that science, I would like to say that we are always doing, there is only one level of research. There is nothing like best in Kerala research, best in Bangalore research, best in India, or something. There is only what I think globally. If you are competing with the best, you are publishing, people will acknowledge you, people will know your work, and that's what you should aim for. And there is always this fascination, particularly some institutes and people write GRE, people write these things, fly abroad, and all is good in abroad. And once you land there, you realize, oh, no, why I came here. So some of our students also got into such type of situation. So I generally say, if you wish and have plans, so if you are thinking like, look, I know of this particular group in Max Planck, or this particular group in US, somewhere else. So I want to work there. You do your homework, then that's fine. Otherwise, don't go with the flow. I rather stay away from the flow, because you create a trend, and you believe in yourself. If you are good at something, I think you should be able to go beyond at the basic level. Yeah.
Sir, last question. How it is possible to determine number of stars in a galaxy when there is such a wide array of stars with different masses?
Yeah, this is just an estimation. Nobody will go and count these billions of stars, obviously. So we just do that from basic first principles, mentioning that, okay, so there are lots of surveys which are happening. And from that surveys itself, as I said, the telescopes or the space facilities scan different regions of the sky. But in spite of all the hard work, you will maximum get, let's say, millions of stars or a billion stars. You can't cover all these crores and crores of stars, right? But there is this estimation coming from the very basic argument. For example, this much region, this much stars are there, and it's homogeneously distributed. You will be having such a bigger number. That's it. Yeah. So there are lots of popular books. So what I suggest as a final point is two points. If I'm concluding this, one is there are lots of popular books available, and many of those books are either in black holes or cosmology, as you see. Yeah, but there are interesting books on stellar astronomy, stars, and galaxies, observation thing. Very simple books. So you go and identify these, and if you happen to go to a bookstore, see that. You go through these, and if you feel good, buy those or read that, and thereby expand the horizon. And also want to say that we have me and my colleagues. There is a research group in Christ University. So apparently, we had done quite some hands-on analysis and training sessions way back, like a couple of years back. So my colleagues are there, Professor Paul KT from our HOD, then Srija Karta, Dr. Srija Karta, Dr. Vineet. These people are particularly in astrophysics. Also, we have a very strong group on material science there. I think a couple of my colleagues, yes, Madam has messaged, Kunyamana Madam, she apparently is in material science. So I think the anti-management also supporting in that aspect to develop our research. So my suggestion to all my colleagues or friends also is there are grants, all these things which are also available. And for students, I think you identify mentors. I mean, so sometimes people are, we all are tied up to a certain extent regarding the students and research team and all. But then I am pretty sure that there are many colleagues who are doing research and work in astrophysics in Kerala itself. Many of us meet during many of the meetings. So if you happen to see that one of your teachers or somebody is doing that, you go to them, talk to them, and then start doing something, and then you can develop it to next level. So if in case of any suggestion or any help or advice, let me know. Yeah. So what I'm overwhelmed to see such a huge number of people participating in this talk, and it has gone beyond our required time, and I think so. We always have this greediness of covering lots of topics. So I think I controlled and restricted myself to a certain extent today. So thank you to Principal, Vice Principal, IQAC Chair, Sonia Madam, and all the other faculties. My friends from Physics Department, I don't know whether they are present. It's Mercy and Phoebe. I mean, so I wish to see you people directly after this. After we come out of the corona situation. Thank you.
Is there anything else? Shall we wind up the program? Okay, Nivedya, please.
Yeah. Thank you, sir. Thank you, ma'am. Next, I would like to invite Mrs. Deepthi S. Nair, HOD from Department of Electronics, for the word of thanks.
Good afternoon to all. Respected Principal Dr. Bridget Paul, Vice Principal Father Dr. Xavier CS CMI, IQAC Coordinator Dr. Matthew Twitelli, respected and our most distinguished Chief Guest of the day, Dr. Blesson Matthew Sir, Dr. Sandhya C. NAC Coordinator, Joni Sir, teachers and my dear students. We are extremely happy to organize such a webinar, and I deem it a great honor to propose vote of thanks to all who have made this webinar a fruitful one. First of all, let me express my gratitude to our principal, Dr. Bridget Paul, for her presence and constant support towards this seminar. And I would like to thank our Vice Principal, Father Dr. Xavier CS CMI, for his moral support and guidance. And we express our sincere gratitude to Dr. Matthew Twitelli, IQAC Coordinator, for his valuable suggestions and guidance. And our words may not be capable of communicating our sense of gratitude to Dr. Blesson Matthew Sir for gracing today's session. And thank you, sir, for your very interesting and excellent presentation. We all are really inspired by your words. Thank you, sir. And let me express our gratitude to Dr. Sandhya C., our NAC coordinator. And I would like to express my sincere gratitude to Professor Joni Thomas, our course coordinator. And we express our sincere gratitude to all the teachers, not only from our college, but also from various other institutions. And I take this opportunity to thank my colleagues, especially Ms. Sonia NB, faculty coordinator of this webinar, for her efforts towards the webinar. Thank you, Ms. And a big thank you to Mr. Shibin Simon for his sincere efforts towards this seminar. And finally, the wonderful students who have turned up in such a great number, not only from this institution and from various other institutions. Thank you so much for your cooperation and patient listening. And special thanks to Ms. Nivedya Raj, our student coordinator. And once again, I thank you all for your cordial participation. Thank you and have a nice day. Thank you.